Hello everyone, this is your video key for problem set 7.6, solving rational equations. So let's get right to it. Alright, as you probably should have heard in class by now, there's two ways to kind of think about these problems. One is, since we're dividing by a variable, you can multiply by your denominator, like on both sides, just as if you were doing x over 3 equals 7, you'd multiply both sides by 7. Here we can multiply both sides by x, which will get the x's on the left side to cancel, like so. And then you just have 5 equals 12x. And then you can divide both sides by 12 and get 5/12 equals x. So that's one way. The other way is two fractions are equal only if their numerators are equal and the denominators are equal. So if you have 5 over x equals 12, you can give 12 the same denominator as the left side, so multiply top and bottom by x. And now, since the denominators are the same and the numbers are equal, you know the numerators must be equal, and you get 5 equals 12x, which is exactly what we already did. So I might just do different problems different ways just so you can see both, but really you can choose which way you prefer. So let's go over to B. Notice how on B we have two fractions over here, so let's make that a single fraction. Once you have that as a single fraction, then you have a fraction equals a fraction, so you can set the tops equal to each other, and then the bottoms become unimportant, because once the denominators are the same and the numbers are equal, you know the numerators must be the same. So same step here, multiply top and bottom by x on this one. And then we can, but now this has a 9, and this doesn't have a 9, and this doesn't have a 9. So we're trying to get a common denominator amongst all fractions here. So multiply top and bottom by 9 here, and top and bottom by 9 here. And so now you have 27 plus 4x over 9x equals negative 45 over 9x. So this negative, you can kind of attach it to the numerator or the denominator, but not both. Typically just put it in the numerator, that way your denominators stay the same. And so now since our denominators are the same, we can just set the numerators equal to each other. 27 plus 4x equals negative 45. Subtract 27, and you get 4x equals negative 72, so x equals negative 18. Okay. You should be checking these for extraneous solutions also, because when you get a common denominator like in D, you're going to end up potentially with a quadratic. In fact, you will end up with a quadratic here. You'll see that when we get to that problem. And so a quadratic, we know, can cross the x-axis twice. And so you've created an extra solution that didn't exist to begin with. So you got to check your answers. I'm not going to go through the checking part. I will tell you if an answer is extraneous or if a solution is extraneous or not. All right, now let's do this a different way. Let's, to get rid of a denominator, just multiply both sides by the denominator. So I'm going to start with this problem by multiplying both sides by x plus 3. That means you got to do this whole side by x plus 3, though, so it's going to be distributive property. If you do it this way, your denominators just cancel, leaving you with 3x on this side equals, now it's x plus 3 times 12, so that's 12x plus 36. And then these x plus 3's cancel because you're distributing this whole bubble. So it's x plus 3 times 12 is that. X plus 3 times this fraction, the x plus 3's cancel, leaving you with just 7. And then get the x's on the same side, so I'm going to use a different color. Subtract 12x to get negative 9x equals 45. So x equals negative 5. Okay, coming over to D. Let's do this the common denominator way. It doesn't really matter. It's up to you, personal preference. On this one, if you do the way we just did part C, you'll have to multiply both sides by x minus 7. to get rid of this, and then multiply both sides by x plus 4 to get rid of that. Or get a common denominator, which really is the same math in the end, because you're going to multiply top and bottom of this by x plus 4. So that's the same as multiplying by x plus 4. On both sides, I mean, not exactly the same, but it's going to be very similar. We need to multiply this fraction by x minus 7 on top and bottom. Squeeze that in there. And the 5 needs to get multiplied by both, x minus 7 and x plus 4 on top and bottom. So once you've done that, we now have a common denominator. These are the same everywhere. And so we can ignore those and just set the numerators equal to each other. Or, algebraically speaking, multiply both sides now by your common denominator, and then the common denominator cancels everywhere. So on the left side, we have 2x plus 8 after you distribute, equals just x minus 7. And then plus we have 5 times, the pink things multiplied together are x squared plus 4x minus 7x, so minus 3x minus 28. Then we got to distribute the 5. So 2x plus 8 equals x minus 7 plus 5x squared minus 15x, and 28 times 5 is 140. Okay. And then we have a quadratic now, so let's set this equal to 0 and see if we can factor from there. So I'm just going to move these two terms to this side and combine like terms, giving me 5x squared. I'm going to write it on the left, but I'm really moving everything over here to the right. So you have 5x squared, then you have negative 15x, and x is negative 14x, minus another 2x is minus 16x, and then what do we have here? Negative 7, negative 147, minus 8 is negative 155, equals 0. And then real quick, we're just going to go to the key that I've already made. Oh, apparently I didn't solve that one. I don't know what happened there. Sorry about that. But you try to factor this. If it's not factorable, then use quadratic formula. Okay, so I'll leave that part for you to do. On E, now this one's slightly trickier because this is not factored yet. So factor this, figure out what the denominator should be. I'm also going to factor the numerator. Well, I'm not going to factor the numerator yet. You can, but to see if common factors cancel. So this is x minus 8, x minus 2 equals 2 over x plus 2. And now I see that I don't have any common factors to begin with, so I am going to factor the numerator into 2 times x minus 2. And that allows me to cancel this x minus 2 to begin with. And so now we just need x plus 2 on this side and x minus 8 on this side. So if we do that, we get x plus 2 over here on top and bottom. And we need x minus 8 on top and bottom over here. And so now on the left side, we have 2x plus 4 equals 2x minus 16. And if you subtract 2x from both sides, you get 4 equals negative 16, which means no solution. Just seeing if that's what I got earlier over here. There it is, same thing. All right, let's do this last one the other way, where you multiply by the denominators to get rid of them. Just so you can see that again. Again, do these whichever way you prefer. First thing we're going to do is factor. So take out an x, and I get x minus 1 equals 1 over x minus 1. So now I'm going to multiply both sides of the equation. So not top and bottom here. I'm doing whatever I'm doing on the left side, I'm doing on the right side. So this is a legal step. And when that happens, these x minus 1s cancel because they're both common factors. And so that creates an equation of just 2 over x on this side equals 1. Now you can multiply both sides by x to get rid of the other denominator, and you get 2 equals x as your answer. Plug it in, check for extraneous solutions. But there you have it.